Hello, Professor. This is Priya Burgu, and today I'm going to talk about how machine learning is solving the binary function similarity problem. Let me start by giving you some overview of this topic. This research focuses on the importance of effectively measuring the similarity of binary code in different areas such as machine learning, program languages, and security. Over the past 5 years, the researchers have developed several articles based on their ongoing work. They also described their systematic approach, starting with how the current research is organized, where the authors identify the re-implementation representation approaches from three different research communities. This involves taking methods previously proposed in these communities and implementing them again to evaluate their effectiveness. Overall, the research aims to enhance our understanding of binary code similarity, which has applications in diverse fields through the systematic and evaluation approach. Um, in the next slide, we're going to talk about the reproducibility. Let's first talk about the word reproducibility means. Making sure that the results are trustworthy and can be relied upon. To achieve this, it suggested that studies break down their researches into clear and replicable parts using a modular framework and re-implementations. This way, others can easily recreate the study and verify its findings, making their research more credible. Transparent and repeatable research is crucial for the progress of a field. Where research is conducted in a clear and replicable manner, it allows other researchers to build on what's already known. Currently, any mistakes and create a more reliable body of knowledge. Here, our main idea was to provide a study of comprehensive understanding of the challenges, approaches, and discoveries in the field. By making the research process transparent and the results reproducible, researchers contributed to strong and reliable foundation for future advancements in digital similarity studies. Well, in the next slide, we're going to talk about the measuring progress beyond specific techniques. The researchers emphasizes the main, the the aim of assessing progress in overall field rather than focusing on one specific techniques. By taking this approach, and researchers to seek gain more comprehensive understanding of the current state of the art in digital code analogy. Well, in other words, they're interested in measuring advancements that span various methods and approaches within the broader field of research, providing more holistic view of progress in the digital code similarities. Here, we're going to talk about the addressing opaqueness of results. Making research findings clear and easy to understand is important. In this study, they are addressing the issue of unclear results by conducting a thorough measurement study. This involves carefully measuring and explaining their findings to make them transparent and easy for other groups to know. Additionally, the study suggests that their work allows for a more careful interpretation of results compared to individual papers. They aim to present a detailed and understandable analysis to improve the overall clarity and reliability of their findings. And the consistency is another challenge they're tackling. To do this, the result recommends using a modular framework and re-implementations. This means breaking down the research into smaller, replicable parts, making it easy for others to reproduce the study. This approach helps to ensure that results are consistent and can be validated across different research efforts in the field. Well, next is the importance in security research. In the field of security research, understanding binary function similarity is crucial. When dealing with tasks like software reverse engineering and analysis malware, it's essential to compare binary functions. Matching unknown functions to labeled one can save a significant amount of time and effort. This process helps identify and category functions effectively. However, determining similarity between binary functions is challenged due to different compilation settings. This difficulty becomes partially critical in situations such as identifying vulnerabilities and reverse engineering process, where accurate analysis and quick recognition are essential to ensure the security of the software system. Uh, Here we're going to talk about the fuzzy hashes and embeddings. In this slide, we're going to talk about hashes and embeddings, which are important for calculating similar hashes from input values. Fuzzy hashes work in a way that even small differences in input values results in similar hashes. This is especially useful when dealing with raw executables, where minor changes can significantly affect traditional fuzzy hashes. The researchers emphasizes the importance of specialized hashing methods like function sim search, designed specifically to handle constraints related to function similarity. And additionally, the study explores the use of embeddings, which which map similar inputs to nearby points in low dimensional spaces. There are two main types of embeddings. They are code summarization and graph structure summarization. The code summarization generally focuses on capturing essential feature of codes, while the graph structure summarization concentrates on summarizing the structure aspects of graphs. Well, next slide is about graph embedding. In machine learning, graph embeddings are like condensed representations of how commands or instructions flow in a program, especially in control flow graphs. These graphs show the sequence of instructions in a program. To understand this complex relationship, we have neutral networks designed for graphs, such as graph matching networks, which is GMN. They help capturing the intricate connections with control programs. To make this representation more richer, we look at the details from each fundamental unit based, basic block in control flow graphs. These details can be easily designed by experts or learned automatically from the data. To make this graphs representation even more powerful, we add extra layer of computation. Think of these graphs are refined and deepening our understanding of relationships and patterns within the graph. This step-by-step process gives us a more detailed and comprehensive picture, making the graph embedded more effective for machine learning tasks. Implementation tools. The research used a set of powerful tools for different analysis stages. For instance, if you talk about ID Pro 7.3, a. It is a well-known debugger and dissembler. Uh, was used in the binary evaluation phase, which uh, which is good at breaking down the structure of binary code. Python scripts working with IDE and Pro APIs were used to extract features, ensuring a thorough analysis of important aspects from the binary data. For the graph analysis, if we talk about network X was employed, providing a strong framework to examine the structural relationships in the data. TensorFlow 1.14, a versatile open source machine learning library, was primarily used for implementing neutral network models. However, the Trex models was an exception and was based on PyTorch sequence modeling toolkit fair sequence, showing flexibility to accommodate different model requirement. Uh, for executing instructions embedded models, GenSim 3.8 along with ASM2 was used. This combination provide effective in modeling representation at the instruction level. The careful choice of these tools reflects a comprehensive and adaptable approach, ensuring successful execution of analysis, featuring extraction and the implementation of neutral network models in the research. Well, the next slide is about our data sets. In this study, in a study about comparing binary function, researchers made two set of data. One is data set 1 and another one is data set 2 to handle the challenges to seen in the real world applications. These challenges include variations in compiler optimization, compiler types, and software kinds. By putting these challenges into the databases, the researchers wanted to mimic the diverse condition found in the real world. Um, you know, they use these data sets in two main ways. First, they teach the machine learning models using dataset one, so the models learn the pattern in that data, and then they check how well these models do by testing them on both dataset one and dataset two. This testing helps see if the models can change the complexities of real world situations in comparing binary functions. And then next, we're gonna look dataset one and dataset two in details. Now it's about dataset one. Dataset one comprises seven prominent open source projects, and after the compilation process, it encompasses a total of 24 unique libraries. The compilation process itself involves the use of GCC and Clang compilers, and each library spans for four major releases, converting the time period from approximately from 2015 to 2021. The data set is substantial, containing 5,489 binaries and a staggering total of 26.8 million functions. Each binary project within dataset one is standardized with 228 arrangements, establishing a robust foundation for detailed and comprehensive analysis with the research context. And in detail, we're going to talk about the dataset two, which is dataset 2 serves as a complementary set of data in the study distinct from dataset 1. In constructing dataset 2, the researchers choose 10 libraries, ensuring they don't overlap with those in dataset 1. These binaries used dataset 2 were provided by the TREX authors, and the purpose is to validate the results obtained from the models trained on dataset 1. Additionally, dataset 2 is examined using TREX methodology. uh, the TREX emulator uses in this study has limitations regarding the architecture and bitness it supports. Consequently, it couldn't be pre-trained or adjusted on dataset 1. Despite this limitation, dataset 2 includes binaries compiled with GCC 7.5, covering four optimization levels and platforms such as X8 x86 or x64, ARM 32-bit or MIPS 32-bit. In the simpler term, dataset 2 is a separate set of data with different libraries, and it helps to ensure that the models developed on dataset 1 perform well on a variety of the binaries. This dataset includes binaries compiled under various optimization levels and for different processor architectures, contributing to more comprehensive evaluation of the model in diverse scenarios. In the next slide, we're going to talk about the challenges in comparing machine learning models. The researchers talk about difficulties in comparing machine learning models, especially when dealing with complex systems like deep neural networks, etc. There are many factors to make it tricky to compare these models, such as differences in how they are optimized and phases of training and functions used to measure success. Now, there's so many deployment strategies, configurations, and various mode techniques. To overcome these challenges, the researchers took a specific approach. Took a various approach. Um, the approaches such as they made sure that all frameworks were trained using same random generated data set. This method was intentional to ensure fairness in comparing models. It provides a standardized basic for evaluating how effective the models were while reducing the potential impact of uh, biases that could be come from using different data sets. By recognizing and dealing with these challenges, the researchers aim to make the comparison of machine learning models, especially the deep neural networks, more reliable and valid. In other words, we can say that they want to ensure that the results of their analysis accurately reflect the performance of the models rather than being influenced by various factors that could introduce bias. In next slide, we're going to talk about the model evaluation results. In evaluating different models that embedded a function into a vector, the graph-neutral network stands out by achieving the best results across various metrics and tasks. The GNN model, which is the graph-neutral network, in particular excels in the task of representing functions as vectors. However, it's worth nothing but while the models perform similarly on an area under the curve metric. These measures the overall performance that are variations in their performance where considering specific metrics such as MRR 10. The MRR means mean reciprocal rank at 10. These metrics focus on different aspects of the model's ability, and the variations highlight that the different models may have strengths or weaknesses in specific tasks in the border evaluation context. Key observations. The research discovered interesting findings in different evaluation tasks. Stress performed better than ASM2 vector in tasks involving different computer architectures, and both architectures and optimization variations. Uh, this highlights the strength of text transformer based method in dealing the diverse hardware and optimization setups. However, in tasks involving different program languages, both models showed similar performance itself. This study is also the study also looked into how instruction embeddings impact uh, graph neutral network features, comparing to bag of words of opcodes or individually designed features. Instructions embedded provide superior in tasks related to normalized assemble. Additionally, the research explored the importance of manually engineered features in GNNs. The bag of words of operation codes are consistently performed well across various metrics, while uh, while the individual engineering features were more effective for specific tasks. These detailed findings provide insights to the strengths and weaknesses of the model and offers valuable information about how they perform in different evaluation processes. Uh, if we talk about the benefits, large training datasets offer significant advantages, especially for neutral network models. The wealth of the data provides a dependable growth truth, meaning a reliable and accurate reference upon a dataset are constructed. With this extensive and well-labeled data, the neutral networks models can accurately represent a wide range of functions and generalize their understanding. In simple terms, having a large and having a diverse training dataset helps the model learn more effectively and apply its knowledge to new unseen situations. The future works. This study suggests future research direction to advance artificial intelligence models to perform similarity. One important area is exploring different designs and applications of graph neutral network to understand their nonsense better. Uh, there's also a need to investigate innovative ways of integrating assembly instructions encoded with these models to improve uh, synergy. Optimizing training strategies and developing customized loss functions are highlighted as crucial area for future research. Addressing these aspects is expected to contribute to the ongoing improvement of artificial intelligence models, making them more robust, adaptable, and efficient in real-world applications. Finally, if we talk about the conclusion, I'm going to conclude in conclusion, the report recommends rigorous evaluation procedures for assessing new features in realm of binary function similarity. Scholars are encouraged to critically evaluate novel advancements with a common framework, distinguishing between improvements that genuinely advances the state of art and those that may seem promising but lack of real impact. A significant contribution of this work is the open release of all applications, datasets, and unprocessed results. This transparency is valuable because it provides a solid foundation for future research. By openly sharing these resources, the authors make it easier for others to evaluate new ideas using a shared framework. This approach promotes a better understanding of development in the field, fostering collaboration and ensuring that the advancement are impactful and contribute meaningfully to the state of the art. Thank you so much, Professor.